Good day, everyone. Welcome to our lecture for today. Our topic for today is about derivatives of algebraic functions. This is a very long topic class, so we are going to divide it into several parts. But the main focus for today is the explanation of the formula of the derivative, how it is derived. But I'm also going to give you the overall objectives of this topic, the derivatives of algebraic functions. Alright, so these are the objectives. At the end of the period, or shall we say at the end of this topic, you should be able to interpret the concept of derivatives, use derivative to find the slope of the curve, find the equation of tangent and normal lines, apply the rules on differentiation to find the derivative of algebraic functions, apply the product and quotient rules in differentiating functions, apply the chain rule in differentiating functions. Okay? So derivative of a function. So let us first have the definition. Let f be a function which is defined at each number x sub 0 in some open interval a, b. The derivative of f at x denoted by a prime of x is given by the formula f prime of x sub 0 equal to the limit of f, the quantity x sub 0 plus delta x minus f sub x sub 0 divided by delta x as delta x approaches to 0, provided that the limit exists. So if the limit exists, then this formula is true. Okay? Now let's go directly to the derivation of this formula, the steps of how this formula is being derived. Okay, so let us have here the Cartesian coordinates, the x and the y axis, and we have the function represented by this curve, and let point PO be at this point, and let a line pass or intersect at this point. We call this as our tangent line. We denote this by LT, and the distance of this point from the y-axis, okay, so this distance we call it as x sub 0. Okay, if you can see a number or a variable that is placed at this point, something like this, so it means that this one represents the distance from the y-axis towards this point, which is equal to this one. Alright, now the value of the function, meaning the y value when x equal to x sub 0 is equal to f sub x sub 0. Okay, so it means the height of the function, so we call it f sub x sub 0. So the value of the function when x is equal to x sub 0. Okay, and let another point P located here, or shall we say let this point move to this point. We call it P. So P has the coordinates x and y, but we use x as x sub 0 plus whatever is the distance from this point, the horizontal distance between p sub 0 and p. We call that delta x. Okay, so call that distance, the horizontal distance between these 2 points p sub 0 and p, equal to delta x. And we can write the distance from the y-axis towards this point here as the sum, the sum of x sub 0 plus delta x. This one, or you can put it here. Okay. Now the value of the function at this point, so we call it as f sub x sub 0 plus delta x. So it means the height of this point from the x-axis is just the value of the function when x is equal to x sub 0 plus delta x. Okay. Now let this line be our secant line. When we speak of secant line, class, that's a line that will intersect the graph at 2 points. Okay, so the secant line intersecting this point here and this point. Okay, so it intersects 2 points. So this is our secant line. So our secant line intersect this 2 points of the graph. This point P and P sub 0. Okay, so this is our LS. LS means secant line. Now if we move to another point, shall we say this point moves here, it means that the secant line moves at this point. So what we have noticed is that our delta x becomes smaller, right? This becomes smaller. So when this point P moves here, our secant line, this is our new position of our secant line. Okay. Now if we move further to another point, shall we say here, so our secant line is now approaching the tangent line. Okay, so as we move farther, our secant line is approaching to tangent line. So notice here that our delta x is decreasing. Alright, can you see it? First our point is here, point P. Then we have here delta x. Then as this point moves down to this point on this graph, so our delta x is decreasing, and if it moves further down, so the more that our delta x decreasing. Okay, if we move farther down, say at this point here, so what will happen is that our secant line is approaching closely to the tangent line, and our delta x now is approaching. What will happen if the tangent line, or this point here, approaches to P sub 0? So in this point, so originally point P is from here, it moves down this point to this point to this point, and if it moves further and up to this point, so we will say that the secant line is approaching or approaches the tangent line, and our delta x is approaches to. What will happen to our delta x? Our delta x is getting smaller and smaller, and it approaches to 0. Okay, it approaches to 0. Alright, so now I'm going to show you um, individually, how this point P moves closer to uh, P0. Alright, so this is what we had done a while ago. I'm just doing it again, but this time we are moving the point P closer to P sub 0, and you will see that the delta x is decreasing. Alright, so that was the second position. Now, as you see, point P is now getting closer to P sub 0, and you've seen here that the value of our delta x is getting closer, and as you have seen, the value of the function at point P is also getting smaller, and it also approaches to f sub x sub 0. Alright, and as you see, the tangent, or sorry, the secant line is also getting closer to the tangent line LT. Okay, so furthermore, so this time we'll see that our point P is now very close to P sub 0. Okay, and our delta x now getting very small, and as you see, our value of the function at point P is now very close to f sub x sub 0. It's approaching this value. Alright, so if we are going to move this point P farther, class, what we will notice is that our delta x is approaching 0. Okay, and if you see that the triangle that we formed from the beginning, which is a bigger triangle that is composed of this line, okay, and also the vertical line from the point P, and the function graph is now getting closer to a right triangle, right? So it means that if we are going to move farther this point, if we move this point farther down to P sub 0, so as P approaches P sub 0, for example, the point is here. If, for example, the point P is here already. Okay, so what will happen is that our tangent line, okay, so our tangent, our secant line will be uh, very, very close to LT. Alright, so we have a line that is now very close to tangent. Our secant line will move down, okay, it will touch at this point and also touching this point here, but now it's very close to LT. So we can say that as P getting closer and closer to P sub 0, our delta x is, because this is now our new delta x, right? This will be our new delta x. As delta x approaches 0. Okay? So what will happen is that we will form a right triangle, class. So we will form a right triangle. You see this triangle here, which is not really right triangle at the beginning because of this curve, and now it becomes a right triangle as it approaches to P sub 0, as P getting closer and closer to P sub 0, and our delta x is getting closer to 0, because at this point here, our delta x is equal to 0. Okay? Our delta x, it means there's no increment from the original value that is x sub 0. So as this point moves closer to P sub 0, our delta x is approaching to 0. Okay? So this is our basis now of deriving the formula of the derivative. So what does it really mean, derivative? So actually, class, that's related to slope. You see, if you can still remember that if you have a right triangle, when you speak of slope, the formula or the definition of the slope is rise over run. Okay, so I will show you how this formula of the derivative is being derived. So from this illustration, we can say that this is our delta y, or that is the difference between the two values of the functions. We call it delta y, and this is our delta x. Alright, okay. So I'll just delete this part here. I just want to clear this up. Okay, so this is our delta y and this is our delta x. So from a right triangle, when you speak of uh, right triangle, the slope of a right triangle is defined as the rise over run. Okay, so here, this height here, height of this point from the x-axis, this is defined as f sub x sub 0 plus delta x. So meaning this is the value of the function at this point, which is equal to, you substitute this value to the function, then you will get this height of the function. And for this one, for this point here, this is just the same as this. So this is our f sub x sub 0. So therefore, our delta y is just the difference. You see, this is just the difference between this height, okay, which is this one, and this is the result, and this height. If you subtract this height of the function and also this height, then you will get the difference, that is the delta y. On a similar manner, we have delta x. So what is delta x? This is also the difference between this distance, okay, from the y-axis, no, from the y-axis towards that point here, okay. This is x sub 0 plus delta x. When you subtract this distance by this distance, meaning x sub 0 plus delta x minus delta x, what is left is the delta x, this delta x. Okay, so we have now the ratio between rise over run, because we know that the slope is defined as rise over run, no, from our analytic geometry. Alright, so let us watch this video class.